Hello and welcome to our podcast. Today we're going to talk about nuclear power, the history and the future. In 1945, 2 bombs were dropped on 2 separate Japanese cities, killing 246,000 people. These were the first uses of nuclear weaponry, revealing the massive power of radioactive material to the world. While our first instinct may have been to use this power for war, we soon realized that it could be used to support our increasingly energy-based lives. The theory behind nuclear power actually came before the weapons were ever produced, directly after the development of the first nuclear reactor. In 1951, this first nuclear reactor was used to supply energy power to 5 light bulbs. Experimental Reactor 1, as it was called, was not originally designed to create electricity, but was instead designed as a proof of concept for breeder reactors. It just happened to be able to produce electricity. In succeeding to create energy to power these light bulbs, it proved that nuclear power was a possibility. As such, the USSR built the first nuclear power plant in Obninsk in 1954, providing 5 megawatts of power. APS-1 Obninsk was essentially a proof of concept for grid-connected nuclear power plants. After this, the US was able to create their own grid-connected nuclear power plant with Breeder Reactor 1. Many other nuclear power plants were soon made on both sides of the Iron Curtain as a direct result of the Cold War. The expansion of nuclear power plants eventually resulted in the creation of Chernobyl, the site of the greatest disaster that happened in the history of nuclear power. Chernobyl was a nuclear power plant in Ukraine that had a massive meltdown resulting from an unexpected power surge. Thanks to the faulty Soviet equipment, the power surge burst a reactor vessel and the safety controls failed. The meltdown resulted in nuclear radiation being spread far and wide. Chernobyl was the worst hit, but the radiation reached all the way up to Estonia, where the people were being forced to celebrate outside the Soviet victory in World War II, while the radiation continued to fall. 3 Mile Island, despite often being cited as an example of the dangers of nuclear power alongside Chernobyl, is actually a great example of how modern nuclear safety protocols helped us prevent these disasters. Thanks to a blockage in the filter and a significant amount of human error, there was a partial meltdown, but the safety measures put in place throughout the plant ensured that there was not enough radiation released to even cause 1 cancer death beyond the average. The 90s, after the death of the Soviet Union, continued the development of nuclear power. Safety protocols were improved, especially in the Soviet Union, or in the former Soviet Union, who still lived in the shadow of Chernobyl. In much the same way, the US was being affected by 3 Mile Island as anti-nuclear activists started to work harder than ever and gain mass popular support.
Hello, my name is Gabe Gilbertson, and today we'll be talking about nuclear energy's present. Currently, we look to France as an example of why we should use nuclear energy in the coming future. Now, France gets 75% of their energy from nuclear energy, and they actually make so much that they can export it to other countries, such as Germany. Now, France has a company that manages all their nuclear power plants. It's called Électricité de France. Now, there are companies that would rather you not use nuclear energy because they would prefer you use their energy source instead. And there's also anti-nuclear protesters for examples on why we don't necessarily follow France's lead in the energy game. Now, there are a lot of concerns when it comes to nuclear energy. First off, it requires an intense amount of maintenance. If you do not use the proper maintenance that nuclear power plants require, you will have incidents such as Chernobyl, as Ian mentioned beforehand. And it's probably preferable that we don't. Another thing is nuclear waste, what we'll do with it. Now, the thing about nuclear waste is scientists are actually currently working on ways we can use nuclear waste for extra energy instead, which would be really cool, honestly. Now, another concern is nuclear power plants really don't have efficient ways of protecting against nature currently. As an example being Fukushima. Fukushima was affected by tsunami, and an earthquake, which caused a power plant to melt down. And I think mild human error was involved as well. But if, say, an earthquake can mess with a nuclear power plant, we'd rather, it not, because we don't want another Chernobyl incident to happen because we couldn't control things like that. Here's a nuclear fallout map of the Fukushima plant. Here's some more pictures of how rescue teams work to stop the nuclear meltdown. Alright. Now, nuclear energy is the way to go for the future. I truly believe this. I think it is cleaner, and if we can actually end up using the waste to make extra energy, that means little waste is produced in the process. I mean, next to none. And to tell you more about that, we'll have Ethan.
What does the future hold for nuclear power? Nuclear power's future will be plagued by economic cost and the pursuit of other alternative energy sources. The cost for a nuclear power plant in the United States, a brand new one, is $7 to $8 billion per 1 gigawatt of electricity that it will produce. So if you want a plant to create 1 gigawatt of electricity, you have to have a minimum of $7 billion. The United States has tried to combat this, and in turn, in 2008, set aside $18.5 billion in subsidized loans by the Department of Energy in order to maintenance old nuclear plants, to upgrade old nuclear plants, and build new nuclear plants. The United States government, by the year 2021, wants to have 4 nuclear plants up and fully operational. These plants are already under construction, but their long-term plan is to have a total of 14 nuclear power plants, new ones, up and functional. The cost remaining of these government subsidized loans is $10.4 billion as of 2014. The problem with this is that the Department of Energy has deemed the remaining funds that the government set aside back in 2008 insufficient to meet the goals of the new power plants that the United States wants to build, the maintenance of the existing power plants, and the upgrade of the power plants. This, in turn, as opposed to the alternative energy sources such as solar and wind, the United States government set aside $78.5 billion for the research and development and production of alternative energy resources that is not nuclear. This is a clear sign that the United States government is not valuing nuclear technology as much as its potential could mean with the new technologies. One of the new technologies is that of the fusion reactor. There is one in Germany that they have proved the concept and created plasma out of its reaction. The United States has been working with Germany at this plant, and the fusion reactor concept has been researched and is in development since 1945. So almost 100 years of development will go into the plant before it'll be even thought of as operational. Another new part that the United States is looking into and is going to be building a pilot plant in order to prove the concept is a new Generation 4 nuclear reactor. This reactor will be built in Idaho, and instead of water-cooled, it'll be a high-temperature, gas-cooled nuclear reactor that will not only create energy, but also create massive amounts of hydrogen that can also be used for fuel. Another new technology and aspect that the future holds for nuclear power is that of a different fuel. It would be of thorium. Thorium would require a salt-driven reactor, and it would break it down with other nuclear wastes that already exist. Combined with the thorium would break it down in plutonium and set off a nuclear reaction. Thorium is widely abundant across the world compared to plutonium, but the cost of actually feasibly making this reactor with thorium is pretty substantial. So with that, the nuclear power future across the world in the United States is uncertain, but there are new breakthroughs. But the biggest obstacle that it'll have to overcome in order for us to see nuclear power plants into the future is that of cost and the continual pursuit of other natural renewable energy sources such as solar and wind.